Good day, everyone, and once again we are back together, your favorite uncle on dial, and welcome to our channel. For those of you who are new, if you haven't subscribed, please just make sure that you're part of the family. Hit that subscribe button, and of course, you can always get in touch with us. And our email address is info@mlungisinkosi.co.za. Right, so we are still looking at that May-June 2022 exam, all right, that was written. And I first of all want to apologize for the quality of this question paper. I could not get a PDF of it, so I just took a picture of this one so that I could discuss it with you. So please, if you want to also make a donation, okay, to your uncle and just show some appreciation, you're more than welcome to hit that super thanks, or even tell your parents, to just give a super thanks. And in this case, that's a monetary gift that you can give to us. Okay, right, now let's get into the question. Now they say to us, define an acid they give us two acids rather, HX and HY, that are of equal concentrations. That's very important. Okay, they say these are compared, and the pH of HX is 2.7 and the pH of HY is 0.3. Right, now they say to us, define an acid according to the Lowry-Bronsted theory. Remember that according to the Lowry-Bronsted theory, an acid is a substance that donates, right, hydronium ions, okay, when in solution. So hydronium ions are donated, right? Hydronium ions, or rather you can say it's a substance that donates protons, right, when in solution. Right, now they are asking us which acid, HX or HY, is stronger. Give a reason for the answer. Definitely we're going to have HY being stronger. Why? Because it has a higher pH value. There's a lower pH value, meaning that it has a higher concentration of hydronium ions. Okay, so definitely it's going to be, they said which one is stronger, so it's definitely going to be HY. Okay, so in this case, the pH value is lower, okay, indicating that it has a higher concentration of hydronium ions. Okay, so H3O plus, or you can say H3 plus ions. Right, H plus. All right, now then the next question says, so they take acid HX, they say it ionizes in water according to the following equation. Right, now they say to us the Ka value for this reaction is 1.8 times 10 to the power minus 5 at 25 degrees. Now remember what the ionization constant is. You can always look at it as the Kc value of acids. So remember, when you take Kc value, you always take the product. So it will be H3O plus multiplied by, okay, X minus divided by, remember you don't add liquids, right? So I'm going to take divided by HX, right? Now when you look at that Ka value, that value is quite low, right? So what is it indicating to you? Okay, so for it to be such a low value, it would mean that the denominator is bigger than the numerator. Okay, so now in that reaction, they are asking, is the concentration of hydronium ions, meaning these guys here, higher than, lower than the concentration of HX? So I want you to note, so when we've got a lower concentration, or rather when we've got a lower Ka value, it tells us that it does not ionize completely. That's a reaction. In fact, if I were to, let me try and just indicate with those arrows there. Okay, so you would find that it actually has arrows like this. What is that showing us? In fact, I should put that at the bottom, right? So in this case, it shows us that it actually prefers to go in the reverse direction. So what that tells you is that this acid does not ionize completely in solution. So you are likely to find the concentration of HX much higher than the concentration of your hydronium ions. Okay, so in that case, it means that they're asking, is the concentration of hydronium ions higher than, lower than, or equal to? So our answer in this case is it's lower than. Okay. And what is our, they say give a reason for the answer. So in this case, we know that the Ka value is lower. Okay. So it has a low Ka value, meaning that it has, in this case, there are more, or in this case, we can say there are less hydronium ions. Okay. All right, so we can explain it in that way. So the number of hydronium ions is much less. Okay, so as a result, we know that it will have a lower Ka value. Right. Or you can even state that it does not ionize completely in solution. So as a result, it forms a lower concentration of hydronium ions. Okay. Right. Now the next question. They say learners add 150 cubic centimeters of a sodium hydroxide solution, and they say of unknown concentration. So we don't know the concentration of this guy here. Okay. And they say to 200 cubic centimeters of a 0.03 moles per cubic decimeter hydrochloric acid solution. Right, they say hydrochloric acid, so this is as illustrated below. They say they find that the pH of the final solution is 2. Now that's very important. Assume that the volumes are additive. Right. Now, first of all, they say the balanced equation for the reaction is shown. Okay, so there it is there. And they say calculate the concentration of the hydronium ions in the final solution. So what happened here? We mixed an acid and a base. So it means that they did not completely neutralize each other. And we ended up with a pH of 2. So what does that mean? It means that the final or the resulting solution was acidic. So it means that there was a lesser number of moles of the base in this case, which is sodium hydroxide, right? Of course, some of it reacted with that hydrochloric acid, but of course, there were excess moles of hydrochloric acid, and as a result, the resulting solution was acidic. Okay, right. Now, what I want us to do, they said, okay, calculate the concentration of your hydronium ions. Right, so remember that pH is equal to minus the log of our hydronium ions. Okay, hydronium ion concentration. But now what are we looking for? We're looking for hydronium ion concentration. Please remember this, okay? That when we're looking for that, you're simply going to say this is 10 to the minus pH, okay? Of course, this is when you are converting from logs to exponents, but in this case, just remember it's 10 to the power negative pH. So we're going to say, well, this is 10 to the power negative 2, and so therefore that is going to be 0.01 moles per cubic decimeters. Okay, right. I hope that makes sense, right? So we've answered this. We said, okay, the concentration there is 0.01 moles per cubic decimeters. Okay, and then now I just want to do this one with you. I'm just going to go back a little bit. Okay, I had tried to answer it earlier on. Maybe perhaps I should just continue answering it onto this sheet over here. Right, now I want you to please follow me in what I'm going to do. So now they wanted the initial concentration of sodium hydroxide, right? Now remember, I already have the concentration of the final solution, right? And what would have happened in the final solution? It means some of that sodium hydroxide would have reacted, right? Now, is it possible for me to get the initial amount? Please understand what I'm going to do now, right? Is it possible for me to get the initial amount of hydrochloric acid? Well, of course it is, right? In fact, let me do this. Let me find the number of moles of hydrochloric acid final. And how am I going to do that? I'm going to find, remember I've got the concentration of my hydronium ions. So I'm going to say, well, this is concentration times volume. This is taken from N is equal to C over V, right? So for my hydronium ions, I've got 0.01 multiplied by, but remember, what is my resulting volume in this case? Remember, they said they are additive, so my resulting volume is going to be 350 cubic centimeters, right? So as a result, that is going to be, to convert that to cubic decimeters, that's 200 plus 150. So that would be, divide by 1,000, that would be 0.35. Okay, so now obviously multiplying those two, so I've got 0.0035 moles. So those are the number of moles of what? Of my hydronium ions in the resulting solution, right? But now, would it be possible for me to get the number of moles? So therefore, by the way, because, the ionization of hydrochloric acid, HCl, when it breaks down, it becomes H plus Cl minus. So it means that for every one of that, you get one of that. Remember, H plus is the same as H3O plus. So in this case, it means if the concentration of hydronium ions is 0.01, then it means that the concentration of hydrochloric acid will be the same. So therefore, HCl concentration, right? And what is this? This is the final one, okay? Will be equals to 0.0, in fact, final number of moles, not concentration rather. So this would be the number of moles of HCl final will be 0.0035 moles. Okay, right. Now, in this case, what do we want to do? Okay, in fact, let me just continue on down there. In fact, let me just remove all of this so that you guys can be able to follow in what I'm doing. Right. So what's going to happen is, now please, I want you to follow and listen carefully. Right. So we've got an amount, the final amount of hydrochloric acid, right? That was left. But would it be possible for us to find the number of moles of hydrochloric acid that we started with, right, in the initial mixture? Yes, we've got 200 cubic centimeters cubed, and we've got a concentration of 0.03. So I can say the number of moles of hydrochloric acid that I started with initially would be the concentration times volume. So that would be 0.03 multiplied by the volume, which is 0.2. Okay, remember, if I divide by, that would be, my volume is 200 cubic centimeters, divide that by 1,000, and so that would give me 0.2, and that's the one that I've used there. Right, so it means that the initial moles of hydrochloric acid would have been 0.006 moles, right? Now, remember, these are the number of moles I would have started with. And what happened to them? They reacted with sodium hydroxide, and the number of moles at the end, let me just try to remove that so that I'm able to explain adequately, right? So the number of moles at the end in this case would be, now please, I want you to note, we've got the number of moles at the beginning, right? Which is that 0.06. We've got the number of moles of hydrochloric acid that were left, okay, that did not react. So you can call them excess, you can call them final in this case, right? Which were 0.0035 moles. Now, so that means that the number of moles of hydrochloric acid that actually reacted with the sodium hydroxide would be the ones that were you started with. So it will be the initial moles, okay, minus the number of moles that were there final. So it would be the initial minus the final in this case. So that would be 0.006 subtract 0.0035, and so that would give us 0.0025 moles. And what are these? These are the number of moles of hydrochloric acid that actually reacted. Now, they gave us a ratio in this reaction. And what do you notice? When you look at the molar ratio there, you'll see that for every one hydrochloric acid, 1 mole of hydrochloric acid that you use, you will also use 1 mole of sodium hydroxide. So now I have just found out how many moles of hydrochloric acid I have used. So what does that mean? It would be the same number of moles of sodium hydroxide. And in this case, therefore, so I can make a conclusion. So it means therefore, the number of moles of sodium hydroxide, okay, would be equal to the number of moles of hydrochloric acid in this case, which would be 0.0025 moles. But why is that? Obviously because this is a 1:1 ratio, okay? But now we wanted to find out the concentration. We know that concentration of sodium hydroxide would be equal to the number of moles divided by volume. We have the number of moles 0.0025, and we divide that by the volume. You remember that our volume for sodium hydroxide was 150, so that would be 0.15. Okay, so we can take our calculator there. 0.0025 divide by 0.15, and in this case what we get for concentration would be 0.017, that's moles per cubic decimeters. And that is the initial, or that was the concentration of our sodium hydroxide solution. I hope that makes sense. All right. And by the way, if you did not understand this, I'm assuming you haven't watched our videos on acids and bases. In fact, I would even strongly advise that you start with the stoichiometry videos. Just look for it on playlists, and thereafter look at acids and bases. And by the way, you'll see that those long mark questions always kind of go more or less the same way. Okay. Right, I hope that has been helpful, ladies and gents, and I'll continue to make sure that I dish out this great content for your benefit. Okay, so please don't forget to subscribe for those of you that haven't, and of course you can get in touch with us all the time. Please don't forget to like and share our lessons. Tell as many people. Want to grow this family to be bigger, so that more and more of you can be able to do well in your matric year, or even whether you are in college or varsity or whatever the case may be, you can be able to benefit from this content. Otherwise, I'll see you guys again next time. Please don't forget to hit that super thanks. All right, I'll see you next time. Sharp, sharp.